Hey folks, recording here the last session for the semester. It's chapter 11. I bet this is probably going to be probably 2 videos. All right. It's been a great semester, folks. I appreciate your hard work, all right? I know it's been tough. Keep it strong, keep it going, okay? Okay, let's get this thing going. Okay, so chapter 11. So like I said, this is going to be real short. I will review the learning goals. I forgot to open up that document, so I'll review the learning goals in the next video. So there's also some kind of nice review here of solution concentration units. So that's what this last final chapter is about, solutions. So let's just have a nice review, reminder of all these solution concentrations. So there's mass percent, which would be mass of solute over mass of solution. So don't forget those definitions of solute, solvent, and solution. So let's write that down. Solute, solvent, and then solution. So typically the solute is what we mix into a liquid to be dissolved, that we call the solvent, and combining those two things makes the solution. Okay. So we've used molarity quite a bit this semester. Moles of solute per liter of solution. But we're going to introduce one new solution concentration, which is molality. So molarity and molality are just slightly different, okay? So molarity is moles of solute per liter of solution. Molality is moles of solute per kilogram of solution. So to convert molarity to molality, we need the density, okay? So I'll give you an example. So suppose we have a, let's just say a 1 molar solution of something like, NaCl, okay? So we can say that the solute is NaCl, and the solvent is H2O. Well, to convert from 1.0 molar NaCl to molal, so I'll write that down, molal. So we would say, like, what's the molality, or, how many molal is the solution? We would have to know the density of this NaCl solution. So it's not the density of the solvent water, it's going to be the density of the sodium chloride solution. So suppose that density, so Greek letter rho, for the NaCl solution, let's suppose it's 1.02 gram per cubic centimeter. So now how do I convert that molarity into molality? Well, we can say that that's 1.0 moles of NaCl, so we have that established. But now we need to know the kilograms of solution, okay? Well, we know from the molarity that it was 1 liter of solution, right? And so we know that that 1 liter is 1,000 cubic centimeters, which is the same as 1,000 milliliters, right? And then finally, we recognize here from the density of that solution that it was, let's see here, 1 cubic centimeter and 1.02 grams. However, we recognize it's got to be kilograms of solution. So then finally, I can say in 1,000 grams, there's 1 kilogram. So my 1 molar NaCl solution will have the following molality. So it's going to be 1 times 1 times 1 times 1,000. So that's all 1,000 divided by 1 times 1,000 times 1.02 times 1. So 1,000 divided by 1,000 is 1. Divided by 1.02 gives me 0.98. So my 1.0 molar solution will be 0.98, and we use a little m, molal. And so you might be thinking, those are very similar, so why does it matter? Well, when the density of our solution is much different than the density of, let's say, pure water, then it does make a big difference. Okay? So, but all the same, you should be able to convert from molarity to molality. And we have to remember this process of doing dimensional analysis. So this is good review at the end. We're also going to use mole fraction for solution compositions. And we remember mole fraction is going to be the number of moles of thing A, whatever this thing is, divided by the total number of moles. So if we were to think about, what is my mole fraction of sodium chloride in this solution, I already know the number of moles of NaCl, 1.0. But then what I would have to do is calculate the number of moles of NaCl plus the number of moles of water, right? So my total would be number of moles of species A, the solute, plus the number of moles of the solvent. And I'll have a couple of sample calculations for this coming up, okay?